We need to prove that pressure increment, so this is change in pressure, is given by minus rho v square dou E by dou x, where dou E by dou x is the relative deformation. And second part, we need to prove wave intensity I is defined by P naught square by 2 rho v. So let's do that by taking a cylindrical element. So this point is at a distance x and this point is at a distance x plus dx. These are the positions of these 2 points of the cylindrical element, which are separated by distance dx. So this is when the medium is undeformed. So when the wave passes through it, let's say the displacement of this point is s and displacement of this point is s plus ds. And let's say excess pressure inside this cylinder now is P. So initial excess pressure is 0 because pressure outside is same as pressure inside. And now let's say excess pressure is P. So this excess pressure is same as pressure increment. Now you may be thinking here pressure should decrease, but that's fine, we are taking a variable, so don't worry about it. Even if the volume seems to be expanding, we are defining P as excess pressure because here P is taken as pressure increment. Now we know that bulk modulus of a medium is given by P upon minus delta V by V, where P is the excess pressure that causes the strain delta V by V. And also velocity in this medium is given by root B by rho. So now you can see where are we going with these two equations. So here we got the term of B and excess pressure P. Here we have a term of B and velocity. So if we eliminate B from these two, you can see the relation between pressure and excess pressure and velocity, which is what we want. So let's write B as rho V square. So rho V square is equal to P upon minus delta V by V. Now here you can see what is the change in volume. So that is relative change in length into area. So relative change in length is S plus ds minus S, that is ds, into area is delta V. So delta V is equal to ADS and V initial volume is ADX. So this becomes ADS by dx, A gets cancelled and P comes to be minus rho V square dou S by dou X. So we are doing this whole thing at a given time, so that's why we can write ds by dx is dou S by dou X. So that's part 1. Let's see the part 2, where we need to prove that wave intensity is given by P naught square by 2 rho V. So intensity is power per unit area, and that crossing a surface can be written as Fv. So if we take this area as A, then power per unit area, or let's say the power in this case, so that is F dot V. And F will be excess pressure into area. V is dou S by dot E. So transmitted power, if we write as Fv, that comes to be Pa into V. So we need the term of P and we need the term of V. So for that, let's come to our original equation. So let's say the displacement is S naught sine omega t minus kx. So we know if this is the displacement, then excess pressure is given by Bk S naught cos omega t minus kx, where Bk S naught is the pressure amplitude. And if we differentiate that, dou S by dot E will be this. So we have a term of pressure now and we have a term of velocity also. So we put 1 and 2, okay, that's a bit later. So this is the transmitted power P. So intensity which we need is power upon area. So if we take area on this side, that comes to be P into V. And V is dou S by dot E. So if we from 1 and 2, we put the values of pressure and dou S by dot E and we get intensity to be this. Now we have a term of S naught, but we need the term of P naught. So we just replace S naught by P naught by Bk. So this becomes P naught into P naught by Bk into omega. So if we rearrange that, this comes to be P naught square by B into omega by K. Now, omega by K is velocity and B is rho v square. Now just one so that you don't get confused. This velocity is different from this velocity. So this is the particle displacement velocity and this velocity is the wave velocity. So I hope you don't get confused. So this V is dou square dot E and this V is velocity of the wave. So we put that rho v square here and we get I to be P naught square by rho v cos square omega t minus kx. Now average intensity, we know that for one time period cos square average is half. So average intensity is P naught square by 2 rho v. Alright.